So today we will discuss about the wind energy. So wind energy is also a renewable energy source. So what is wind energy? So wind energy is nothing but it is basically the kinetic energy of the wind. And our intention to convert this kinetic energy of the wind into the useful energy in the form of say electricity. And you know that the wind is basically the manifestation of the solar energy. And you know that the wind blows due to the uneven heating of the Earth's surface. And not only that uneven heating and some other factors are also there, we will discuss. Yes. But mainly due to the uneven heating. Just a minute. So mostly when you will think about the Earth surface, basically, so due to the shape and due to the positions, you will get the higher temperature at the equator and lowest at the pole, and because of that, it will create an uneven heating, and because of that, so it will blow, and will utilize this kinetic energy for the useful power. So now, why this wind energy is getting more importance than the other, so similar like the solar throughout the world. And you might be surprised. So in India is the fourth highest power generation in the field of wind. So because of that, it is clean, renewable. So there is no emissions. So there is no burning of the fossil fuels. So you will get the clean energy. So there is no climate change issue. You will not get any problem with the air quality. So there will be no question of the depletion of the fossil fuels. And, and this is renewable, you will get the energy independence. And you can generate locally. So if you have a suitable location or site, and you can generate power. And so you have a lot of advantages of this we will discuss in a separate slide. So this is a problem. So not stick with the time. Okay, now we'll talk about the origin of winds. So mainly we will talk about the two type of winds. One is the global winds and another is the local winds. The global winds are basically due to the two major forces. So primary force is basically due to the differential heating of the Earth's surface in between the equator and polar region, and another is the spinning action of the Earth. You know that the Earth is rotating, and based on that, it will produce the Coriolis force, and which is also responsible for the deviation of air current towards the west. So that is due to the spinning action. So that is so. So these are two are the primary forces causing the global winds. But we will talk mostly about the local winds. So those are very much essential for the generation of or site selection criteria of the wind mills. So those are basically locally. So localized uneven heating is responsible for the local winds. So differential heating of land surface and water bodies due to the solar radiation. So because of that, in the coastal areas, you will get the winds. And some other locations when you have some differential heating of slopes on the hillsides and that of the lowlands. So basically, upper portion will be mostly if you have some of the locations, if you have the uneven surface. So that is also responsible for the blowing the winds. And some of the location you get a tunneling effect when you have some hills and signed by the you will get the winds. Not only that, if you have some number of high-rise buildings in your particular urban areas, also you will get a particular location, you will get a substantial amount of wind. So these are basically the local winds. And these are the factors these affect the wind distribution. So wind distribution is also vital. So these are mainly due to the great mountain influence, the circulation of air current, surface roughness due to the hills. Basically, if you have some uneven surface or small hilly terrain, you get the wind. And some of the cases when you have some climatic disturbances, say cyclone, thunder, cloud, precipitation effects. So during the cyclone and other, you will get the winds. But those are not in favor of the generation of the power. Basically, you will get the a large fluctuation of it's too much. Okay, so now this figure will itself will give you some idea. So how this wind will blow from this ocean surface to the land surface because of the uneven heating. Basically, so during the two things during the daytime, your land surface will be heated faster than that of the water. So it will flow in the so this left to right, and at the night time also it will give the reverse one. So this is basically the so due to that the coastal areas are mostly favorable for the windmill farms or wind farm. So because of that, if you go to the say Kerala, Tamil Nadu, or some of the Gujarat, the coastal belts, you get a lot of wind farms. So this is the figure you will understand. So this is responsible for the global winds. So due to the uneven heating of the Earth's surface at the equator region as well as polar region. This slide will give you some idea about the advantages of wind energy or wind power. Already I have told this is basically mostly environment friendly, clean, safe energy resources, and it has the lowest gestation period as compared to the conventional energy as well as compared to the biomass also. In case of biomass, you need a certain time, say it may be the 1 year, 5 year, or 10 years. But here it is a so already you will get the renew within a few hours, or not only that within a few minutes. And another advantages of this type of power plants are basically due to this. You have the very less time to get the uh, election and commissioning to have a power plant. Basically, this you need to have some small turbine with the generator as well as some of the uh, okay. So commissioning of wind turbine it takes only few months. So whenever if you have a, say hydro or nuclear or the steam power plant, it takes 3 years, 4 years, as well as more than 5 years. And another main advantages are basically there is no fuel cost. So that is the main advantages of this. And there is no operating cost and maintenance cost is also low because of less complexity. you have a less number of components for these wind turbine generators. And capital cost is also comparable with the conventional power, say steam power plants. And nowadays it is also going to down so due to the technological development of the materials. So nowadays most of the cases people are using the composite materials. Okay, so due to the lightweight, so these are the advantages are there. But you have also a lot of disadvantages. So first one is basically if you think about the wind, solar, so these are intermittent in nature. So always you will not get the wind with a substantial uh, velocities. So you need to have a certain velocity to generate the power. Okay, so then maybe, and this is because of this intermittent, you will not get the power for the 24 hours. I think you don't have any time sense, no? So it is now 10:47. Still, you are making. So this is the last time I will take students. Okay, so intermittent. So that is the main problem. So will not get the power for the 24 hours. Not only that, you will not get the uniform velocity of wind throughout the day. So that is the main thing. And another thing is basically when you have the high winds during the natural calamities, a cyclone, so that you will get a more velocity of wind. So, and some of the cases you will get damage of the wind turbines. You need to keep the precautions during that time. And another thing, when you so there is a variation in the wind uh, velocity, so there will be a variation in the fluctuation in the speed, there will be a fluctuation in the voltage as well as uh, so that is a factor as well as power factor will vary with this uh, the, the wind velocity. So that is the main challenge. And not only that, most of the cases, electronic people, they are doing a lot of research on this particular field to have the to design system to uh, manage this fluctuation of voltage, fluctuation of frequency, fluctuation of speed to have a power that is the utility power. And another problem of this wind turbine also the noise. So this is a rotating device. So not only that in your field, so it will rotate at a particular speed. So it will give you the sound. This sound will be the sound of the wind as well as a bearing sound. Some of the cases if there is some um, problem with the bearing, so you will get some sound. So this is another problem. So, and last problem you can say, so when you have a lot of wind turbines in a particular field, and those are rotating at a particular speed, and birds basically, when the birds will move through these wind farms, so bird hittings. So, the mortality of these basically the birds may take place near the wind farm. So that is another. So basically the people those who are looking to these things, so they may to complain about this parts mortality. Specifically, when you have some of the like migratory birds will come into a particular locations, a lot of birds will come, and during that time they will request the wind farms to stop the generation and to keep the safe passage. So these are the things are there to have the understanding with the environment as well as the. Okay, so these are the limitations you can say as well as the disadvantages. Now think about the potential. I have told that you need a certain velocity of wind to generate power. So depending upon that, so there may be some suitability. Say more than say 20, it is good. So So 25 is good and 30 is also good. But if you have say, less than 15 kilometer per hour, you will not able to generate power. So that is the limitation. So you need to have a substantial amount of making the noise. Okay. So now, when you will think about the wind farm or wind power, installation of the wind mills, you need to think about some of the criteria you need to know. The first criteria, obviously, the high wind resource at a particular site, and you need to measure the wind speed at a particular location, and if there is a variation is not there, so depending upon that, you need to estimate the potential, you need to select the turbines, those are the things are there. And another thing is the adequate land availability. So you need a large area to have the installation of the wind. So you need to maintain a proper gap. So most of the cases people will prefer the buried land. So those are available near the coastal belt. Uh, Not only that, now the people are also installing the wind turbine at the not in the offshore, in the onshore, basically in the ocean also people can install the wind turbine. So you will, so I will show some of the figures so people, and not only that you will get the better wind and that places. And suitable terrain and good soil conditions. So this is also important because you need to install the turbine. So that is a large tower. So soil conditions, load bearing capacity as well as the soil structure is also important for those wind turbines. And maintenance access to the site. So you need to maintain, you need to do the maintenance of the wind generator, or if you have some problem, bearing problems. In most of the cases, you get some problem of bearing. So, so I will discuss about the different components. So mostly you will get some problem with the rotary component like bearing or gearbox. And another thing is the suitable power grid nearby. So those are basically located near the coastal areas. So you need to evacuate the power to the grid. So so nearby grid is also an important factor. So basically, this you will get the power, say in the evening or in the morning. So but you need to transfer the, so obviously to reduce the transmission or distribution loss, you should have nearby grids. And techno-economic selection of the specific turbines. So you need to select the suitable turbine for your specific wind velocity at the particular location. And scientifically prepared layout. So depending upon the availability of the wind, you need to uh, have the proper layout for the installation of the wind turbine to get more power. So basically, our intention to harness more power with a better efficiency. So are you there now? Yeah. So these are the site selection criteria. Now you can visualize some of the schematic diagram or say some of the figure of the wind uh, turbines. So those are basically here. These are horizontal axis. Actually, rotation of axis is basically the horizontal shaft position with horizontal. So it is rotating. Okay. And depending on the number of blades, it may be single blade, twin blades, multi blade. In our Jadavpur University campus, you will get some of the wind turbines like the single blade, twin blade, three blades, as well as multi bladed. Near the Jheel area, near the mechanical building, you will get a large multi bladed wind turbine. That is a landmark of one of the landmark of the Jadavpur University. So these are basically suitable for the low wind velocity. For the very high wind velocity, these are mostly preferable. So basically, you will get the And these are the different types. So depending upon the upwind, basically direction of the wind. So here basically in the opposite direction, it is tying at the backside. But our intention to rotate the shaft in a horizontal axis. Similarly, you will get some of the turbines. So those are vertical axis turbine. In our lab also we have a number of vertical axis turbine. So those are suitable for the low wind velocity. Low wind means so the basically say you have a high-rise building and you want to extract the power, you can install this type of small turbines. So this is a basically you have a small tower. So these are two-bladed, so DDS type of, so these are 7 years type. So basically here there is a specific advantages of these turbines are it is independent of the direction of the wind. So if the wind blows in any direction, there is no change in the, so there is no problem with the generation. So this is basically it will rotate. So this is basically the cross section of this, and so depending upon the wind direction, it will rotate vertically. So these are the different types. So this is basically cup type wind turbines are mainly used to measure the wind speed also. So in the most of the cases, if you have some laboratory, at top of the laboratory, we will get this type of cup anemometer to measure the wind velocity. So here are some of the advantages and disadvantages of this vertical axis wind turbine. So vertical axis basically advantage is the omnidirection. So directional. It will accept the wind from any directions. So that is the main advantage. And components can be mounted at ground level, easy to service, light in weight, so smaller in size, can theoretically use less material to capture the same amount of wind. So basically, less complexity, small towers. Okay. But some of the so these advantages are rotors generally near the ground where the wind is poor. You know that wind will vary with the height. So that is why in the the high-rise building will get a more wind. So with the height, wind velocity will vary. And centrifugal forces stresses on the plate. Basically, it will rotate vertically and it will generate the centrifugal force that will give you the more stress on the plate. So that is the vibration, you will get more vibration. So poor self-starting capability. So that is the main problem of this type of turbine is the poor self-starting capability. So initially, some of the cases you need to provide the initial torque to rotate. So when it will establishes the torque or centrifugal force, get it will generate power and requires support at the top of the turbine rotor. Requires entire rotor to be removed to replace the bearing. Basically, most of the cases, bearing will be placed at the base. So, basically, turbine will rotate vertically. So, you need to replace the bearing so during the maintenance. And obviously, you have that low velocity, lower height. In that case, you will get less power, less performance, poor performance. So these are so that is an idea about the vertical axis wind turbine you are getting. So these are not suitable for the power generation. You have a small installation to have some power of some say street light or say, street light or building lighting. So these are not suitable for the power generation in commercial scale. So these are the figure you can visualize this small turbine. This is a large turbine. Say, so this may be in a megawatt scale. So this amount to the megawatt scale. You can. So these are the things. And some of the cases you will get the turbine height is say more than 100 meters. So this is actually the 28 meters. Think about the size of the turbine. So people are talking about. So, so they will generate the, the power about say the 2 megawatt, 3 megawatt power in a single turbine. So that is the 2 megawatt power is a huge power. So this figure will give you some idea about the different components. So this is very vital. So you need to have a main the component that is the turbine. So this is basically the turbine. So these are the blades. Rotor, we will say this is the rotor. So this will rotate. And and most of the cases, cross section of these blades are basically the aerofoil shape. We will discuss how this lift and drag will act to rotate the turbine shaft. So, so, so there will be a main shaft, and that will connect between this generator as with this, and this is a gearbox. So mostly you will get the speed of the wind is not. So depending upon the speed, so obviously your the rotor speed will vary, and because of you need to rotate your generator at a particular speed, so you need to have the gearbox to adjust the speed. The function of the gearbox is mostly the speed of the generator shaft. So this is the component, and that is basically the housing, and most of the component will be housed in this aircraft that is called the asset. So we'll discuss. So this is basically the so major component is basically the rotor, gearbox, and that is a generator. Okay. So and the type of the generator may be very depending upon the installation or type. So this is so based on the some of the aerodynamic principles. Basically, when you have an aerofoil shape, so aerofoil shape is basically the shape of the fish, shape of the aeroplane, or shape of the bird. So these are basically the aerofoil shape. You get this is the aerofoil shape. When it will blow the wind, so what will happen? It will give you the. So this is basically the two type of the force it will generate. One is the drag force, and that will oppose the velocity, and another is the lift force. So this lift force will be responsible to create the motion. If this blade will hold to at a particular point, so this will try to rotate the blade at a particular shaft. Okay, so that is basically the principle. So depending upon the shape, when you have a plane, basically when it will have the aerofoil shape, that is why it is when it will move in a particular direction, it will try to lift the entire aeroplane or so 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 because of the shape of the blade or shape of uh, the entire uh, body. So this is basically the principles. So most of the cases you will get the aerofoil shape. So this figure will clearly to give you some idea about the different components. So those are very much essential, and you need to understand the function of each and every component. So basically, if you think of half, and this will hold the blades, and this is the main shaft that will connect between this rotor and this gearbox. So function of the gearbox is to speed up the speed of the main shaft. Okay, so this is so this is the high speed shaft, and that will be connected to the generator. And you know the generator is this function to generate the mechanical energy to the electricity. And here there's a arrangement of the brake. So I have told that so during the high wind uh, so due to these natural calamities or say cyclone, so you need to stop the generation. You need to stop the rotation. So you need to stop uh, the entire that is the shaft. It should not rotate. So that is basically the function of the brake is to save save the generator, turbine generator. So are you there? And are you getting now? So these are the different components, and so there is basically housing. This will keep all the things in a particular position, and obviously will save the component. So now we'll talk about this how this how to estimate the power generation, or how the theoretically you can uh, estimate the potential as well as power of from a particular wind. main or wind turbine. So we are the engineers. Our intention to estimate as well as we need to think about the function efficiency. So here, so I have told that. So this is nothing but this is the kinetic energy of the wind. And if you so this is the formula of this kinetic energy, say half mv square. So if you think about the mass of wind, the rho A is the flow area, and that is basically the flow area, and V is the velocity. So based on that, you will get the mass. And if you convert it into this mass into velocity, so ultimately, and this is basically the kinetic of the wind. So the half rho A V to the power Q. So it is directly proportional with the cube of the velocity. So it is mostly related with the velocity and directly proportional with the area. And if you have the large area, so large area means the size of the turbine will be more. So this area is nothing that is a swept area. That is the swept area of the turbine blade. So depending upon that, if you talk about and if you convert this basically area into this in the form of diameter, so these things, the total power will be so directly proportional with the cube of the velocity as well as the square of the diameter of the turbine, wind turbine. So how it will vary? So this is the power, and that is the wind speed. So you know that depending on the wind speed, it will give you the more power. So this is for the say 5, and this is for the say here you have the 10. So you have a large power. So similarly, depending on the diameter. So these are basically for the diameter. So these are depending upon the basically power is directly proportional of the cube of the velocity. So velocity is more important than of the diameter. Now here we will try to estimate so how much power we can generate. So total power, basically total power is basically the total kinetic energy. So that will give, see that is available for the power generation. But it is not possible to harness the entire amount of the power of the wind. So after the strike, so there will be a certain velocity. So inlet velocity will be there, but after striking on the blades, so there will be reduction. So you know that most of the cases when you will talk about the turbine, so this turbine working principle is mainly due to the second law of motion. Rate of change of momentum is nothing but that is a force. So there will be rate of change of the momentum. So at the turbine blade after the turbine striking on the blade, so there will be reduction of the velocity in the magnitude as well as in the direction. So rate of change of momentum will give you the force, and based on the movement or the motion or displacement, you will get the power. So that is the analogy. So here we will talk about that part. So after the striking, so what will be the exit velocity? And depending upon that, there will be a change in the kinetic energy that we will estimate. So here, if you have, so this is basically a particular section we are talking about. So this is the turbine wheel section, and this is a far away from the turbine, and that is also in the back side. This is a far away from the turbine. So here, if you think about the change in pressure, so this is a pressure at the inlet, and there is a far away from the turbine, and there is a far behind the turbine. This is a PE, that is the exit pressure. But when in between the turbine rotor or turbine wheel, so there is a change in the pressure. Okay, so that is basically, so there is change in the pressure. When the change in the pressure is there, so there is change in uh, the, the pressure multiplied with their surface basically area, you have the pressure force. So there is change in the pressure force is also there. The PA is basically at the inlet, and there is a TP. And that is also, and if you look into this at the same location, if you look about the velocity, so there will be change in the velocity. So that is the inlet velocity that is far away from the turbine, and that is the exit velocity, and this is in between the turbine. So these are the change in velocity across So this understanding is completely theoretical basis. So there is a change in pressure is there, change in velocity is there. Basically, we are doing, we are extracting the kinetic energy mainly. And you also know that for those who are has a background with the thermodynamics, you know, and fluid mechanics, not only that in the plus two level, also you know that boundless theorem. So basically, in a particular section, if you have the two sections, if you think about the flow energy, and that flow energy in the form of kinetic energy, potential energy, as well as the datum energy, you can say. So energy at section 1 will be equal to the energy at the section 2 if there is no losses are there. So basically here, if we apply this boundless theorem or energy equation, energy equation, so basically energy at section here will be equal to energy at this point or this section. Okay, similarly, we will do the same thing at this B section as well as E section. So here, this is basically the from the boundless theorem. So here there is a pi, that is a specific volume, not the velocity. This is the velocity pi, and there is a va here. Okay, and depending upon that, this is the pressure. Okay, similarly, if we do the same analysis here, you will get there is a P, there is a PB. Okay, so our intention to determine this pressure difference between these are 2 points, so this A and B. So here, and depending upon the figure, we can see this VI is obviously more than that is PE. So, so depending on the understanding, so this VB is equal to is greater than PE, and PI will be greater than the other as a PI. So PB will be greater. So depending on the understanding, that is the variation of the pressure as well as variation of the velocity, we can estimate the change in pressure in between this turbine wheel. There is a PB minus P, so PA minus PB is basically in the form of this. And but if you look into the far away from the turbine, so this pressure at the inlet is equal to the pressure at the exit. That is the basically the surroundings pressure. And and if you consider this turbine section is basically a small section, this is section is small. In that case, you can consider this VA is closer to the VB, and you can consider this is the VT. So now, and if you consider VA is equal to VB and PI is equal to P, so so this is the equation will be more simplified in the form of, so there is a change in the pressure, and that will be in the form of change in the kinetic energy. That is a VI square by 2. So this will be basically the change in pressure in the form of change in kinetic energy. Now, if we do the same analysis based on this understanding to find out the force. So if you consider you have the projected area, that is a swept area, you in the axial force. If there is change in pressure, obviously there will be a force, and that force will be PA minus PB into area. The, so if pressure is nothing but that is a force by area. So here the force is nothing but that is a change in pressure into the area, and we replace this PA by PA minus PB with this. Okay, so this is basically the force we are getting based on the change in pressure. Same force we can get from the change of momentum. So there is a change in the velocity is there. So if you want to get the force based on the change in momentum, so that is a change in momentum. So here this is a mass flow rate, and there is a change in velocity is basically the at the inlet as well as the exit. So there will be an inlet velocity as well as exit velocity. But theoretically, these two forces are acting on the turbine. So these two forces are equal, And if you do the balancing of these two force, this one and this one, you will get this relation. And if you do the some simplification, finally you will get VT is nothing but that is the mean of this VI and VE. So, so that is the main outcome of this understanding. So this VT, that is the velocity, say at the turbine, that is the average velocity you can say. So this is nothing but the mean of this VI and VE. Now here we are getting the VE as well as this VI. Now as a turbine, we are doing the change of the kinetic energy. So what we are getting in the form of work, so that is a change in the kinetic energy. So change in the kinetic energy means that is the kinetic energy at the inlet minus change at the kinetic energy at the outlet. Okay, now think about the power. So this is the power. If you have the power, that is the m dot. So m is the mass flow rate. So mass flow rate is nothing but that is a rho a into v t. That is basically the velocity. That is the average velocity through the turbine. And if you put this Vt in the form of mean of this Va and Ve, so ultimately we are getting this relation of the power that are actually you are getting basically theoretically you are getting this one. So finally, and this is not the rho, this is the power. There is a printing mistake. This is the power, not P. So this is not the rho, this is P. So this is also P. Now, if you look into this relation, you have some parameter are constant, say rho is constant, A is also constant, Vi is also some sort of constant. Really, this is the inlet velocity. But Ve, that will vary with the turbine, design of the turbine, shape of the blades. Okay, so if you want to extract the maximum power, so depending upon on this relation, so you can do the maximum minima. So you can obtain the condition to have the maximum power, that will be dp by v. So if you do the derivation of this with respect to this v will be equal to 0. So finally you will get, so this is basically if you do the multiplication you will get this one. So you will obtain these two conditions, v is equal to vi, but so this is not possible. So this will be the same velocity, there is no change in the kinetic energy. But there is another condition we are getting, v is equal to one third of the vi. So this is possible or this is acceptable. So this is the optimum condition to have the maximum power. So this is the conditions. Now if you put this value of this VE in the form of VI, if you put here, then you will get the relation of this. So this is basically the maximum power you can obtain based on a particular velocity. In the earlier, it was the half of this, but so this is not the exactly half. So this is basically a particular factor, and this is basically the total power we are talking about in the earlier. So that is the theoretical power, but so this both are theoretical, but this is a total power, and that is the maximum power. Now, based on that understanding, if you do the efficiency calculations, this is the maximum efficiency you can obtain, and that is the value of 0.59. So the maximum efficiency you can attain from a wind turbine. So that is a less than 60%. So this is known as a Bates limit. So these are limits in the wind turbine theory. This is called a limit. So this is maximum theoretical efficiency you can attain. But in a practical case, so this is not that much. It is the part of the maximum efficiency. So here the 0.6, it will vary, but 50 to 70% of the maximum. So hardly we will get the efficiency, say 35% or maybe the 40%. So conversion efficiency is not high. We are getting say 30 to 40% efficiency out of the wind turbine. So this is a theoretical background we are getting to have some of the understanding. So how this wind energy will be converted into the a form of mechanical energy to have the power. Okay. Now, based on the understanding, what we have discussed, if you can able to calculate the power, you can calculate the torque. So these are the standard formula. So this is basically 2 pi nt. We know that this is 2 pi. Power is nothing but 2 pi nt. This is basically you have some rotational speed, you have angular velocity of the wind field. So depending upon that, so these are the formula, but in your syllabus, I will not provide any type of problems. You will only undergo with some of the theoretical understanding, different component, advantage, disadvantage, special issues, so differences. These are the things. So I will not give you any problems. So you are not the mechanical or civil. These are basically mostly in the core engineering, but you have the student of IT, computer science. So I will not provide this sort of information. So these are some of the numericals are there. So these are only for your information for the calculation. So these are basically the theory we already have discussed here. So this is a standard problem. Okay. Now coming to the another understanding area, that is basically the power in duration with the velocity characteristics. Basically here we are converting this velocity into the power. But to generate power, you need a certain velocity. So if you look into this figure, so that is basically the wind velocity, and that is basically the hours, so duration of the hours basically in a particular. And this is the hours, and that is the power. Okay. So there is a particular velocity where you will get the start of generation basically. It will start generation basically. You know that you need a certain velocity to generate the power. So there is cut-in velocity. Okay, that's called a cut-in velocity, and there is a cut-out velocity. Basically, you need to cut the power. Cut-out means there is basically so based on that you can't beyond that so there will be some problem with the generation. So depending on the understanding, if you have the 2 point, there is a cut-in and that is basically the cut-out. In between there will be generation. So and not only that generation will also vary. So here this is basically the 100 kilowatt here, and here there is a, say hardly 200 kilowatt. So there's a variation in the power generation. So depending upon the speed only. So this is basically this depending upon the speed. So say here this is a 10, and so this is basically the 22 or something like that. So there is a so you should know this car. So when you will install or when you will select the turbine, in that case, you should know the cutting velocity, the cutout velocity. So those are the very important parameter. And depending upon that, not only the when it will reach in the cut out velocity, so there will be with the change in the velocity, you can't change the power, and that is the rated power. Basically, rated power. Basically, you have a rated capacity of the generator. Now, beyond that, you cannot, you could not able to generate more power based on. Say you have a 3 kilowatt wind or say generator, you cannot generate more than that. So that is the rated. So based on that, that is basically the frequency and our distribution curve. So these are the definitions. If you think there is cutting velocity, it will start generation, and below which it will not generate the power. There is the design speed, that is the speed of the rotor generator when it will generate, or you will design the rotor, that is the speed, rated speed. It is the speed at which the wind turbine generator delivers the rated power, that is the maximum power. There is cut-out velocity. So during the storm, it is necessary to cut out the power of the wind. You need to stop the turbine to save your system. So here some of the understanding the generating systems. So depending upon the speed, depending upon the frequency, depending upon the operation, there will be number of mode you can think about the generation. Not only the your electric generator may be the different types. So depending upon that, you having some understanding. So those who are in electrical background or power background, they will understand easily with some of the components. So this is only for your understanding. So here you have the constant speed. and frequency system. Mostly we want this type of system, constant speed, constant frequency. So if you have a say 3000, say, so I'm giving some understanding like in that basically when, so depending upon the speed of the shaft or rotor, so your uh, frequency is basically fixed for the Indian country it is 50. So depending upon that your number of poles of the generator will vary. So if you have four pole machine, in that case your speed should be 1500. If you have a eight pole generator, in that case it was 750. So that is a constant speed, constant frequency system. But in case of wind turbines, often you will not get this type of system, but some of the cases you will get the variable speed, constant frequency system. The variable speed, variable frequency system. So depending upon the availability of the power, wind, and the generator systems, you need to have some of the component, the power electronics component to match these type of things, frequency as well as speed. So these are the integrated system. So sometimes you have the alternative that is AC generator. There, that's some of the cases you need the synchronous generator. So depending upon that, you need to, and some of the cases you need the induction generator. So you need to think your uh, a proper a device for your proper system, so to have the better power. Similarly, you have the variable speed, that is constant frequency. So in that case, you need to have some of this type of converter. You should the variable frequency, you need to AC to DC converter. Then you need to convert to DC. Then again using the inverter, you need to convert it. So this inherent another system controller you need to add be- so before we're going to feed into the grid or before going. So these are the things electronic systems you need to add with the system. Similarly, for the variable speed or constant frequency system, also you need to add up this type of things. So, along with that, I will give some information about the hybrid system. So this is basically the inherent another things people are doing a lot of research to make it hybrid. So already I have told that solar, wind, those are intermittent in nature. You will not you will not get the power for the 24 hours or 24/7. So you need to add more system to have make the system more reliable for the power for the 24 hours, 24/7. So here this is a concept of the hybrid system. You here basically you have the wind power plant, you have the diesel generator. These are basically the diesel generator, and this is basically the system for this. You have the AC to DC, you have the battery, so and then will be storage capacity. Here you have the AC to DC, and then AC to DC, then it will utilize. And not only the sound like so directly you can uh, take the AC for your appliances or for your utility. And sound like mostly nowadays people are will prefer not this diesel generator. They will prefer the solar and wind if you have the combined. And some of the cases people will prefer the biomass also. But along with that, they will give a storage bank basically. So this will give you the power. So this is called the hybrid system. So you will generate the power in such a way that you will get the power for to meet your demand. Okay, and battery will give you the uh, rest of the backup. Basically it will store when you have the more power, and it will supply the power when you have the less generation. So that is basically the integrated system. So that is very much essential nowadays, and most of the cases renewable system people are doing in this way. So similarly, this is basically the solar PV. We will discuss elaborately. We have in our course that is solar PV, solar thermal. So that is the wind power. So this is also the hybrid system. We have the reliable power from the renewable energy sources. So this is the figure I can to share you the size of this. So we say this is the 131 feet long. Think about the shape, and these are the integrated the turbine. So this is the large turbine. Okay, so this is the height of these three. The top of the blade is basically the 393 feet. This is a large installation. So these are the things people can. So these are basically the turbine. This is the tower. This is the thing about the weight of that this unit is 56 tons. So think about the structure you need to provide to install this turbine. Not only it will rotate at a particular speed. So these are the considerations. So civil engineers, mechanical engineers, they are doing their best job, and our intention to keep the weight as much low as much possible to reduce the uh, structural stability or structural strength. Think about that, and this is basically the way people are thinking. This is basically transformer will be there. So this is a common thing. Transmission lines. So this is the offshore wind farms. Nowadays, these are most common from the developed countries, but we are also planning this type of turbines. This is offshore. This is offshore turbines. So these are the large turbines. So this is for the and some like it's a residential building. People can think of this type of units. Small unit will be there. So these are the things. And net metering scheme also there. So you, you can supply your power to the grid also, or you can take similar like the solar. So these are the issues already I have discussed. So not to like that. This is the you need to mitigate all the things. And here, think about the sound. So when you have a large turbine, it will generate a certain amount of speed. So that is, and some of the device, so they are generating this type of sound. 50. This is basically vacuum cleaner. So these are basically the. So and if you think of far away, so this is say the 500 meters, you have the power, the sound like this. But near the turbines, you have a lot of sound. So sound, and mostly you will get the more sound when so they have some problem with this some bearing. So you need to take the attention of that. So this is basically the understanding I want to share about. I have found this understanding. So every this 10,000 bars killed by human activities, less than one is caused by the wind turbines. That is the main outcome. So people are more vulnerable than the wind turbines. So that is understanding. Okay. So if you have any specific questions, we can discuss. So we are getting some of the understanding of the wind turbine, the different types, advantages, disadvantages, special features. Okay. No question. Okay. Thank you. I'll share that.
Thank you, sir.
Yeah.
Thank you, sir.